Hello everybody, the iLord Root here, and welcome back to another episode of Kerbal Aerospace program. So, I thought I would go ahead, despite the fact that we hadn't really mastered landing, see what it would be like to fly in the upper atmosphere, and for that purpose I've created a plane called HAT, or High Altitude Testing. And so this thing doesn't really look like it would fly at first. It looks like it's got too much lift on the nose, right? However, we actually have a little bit more lift on the rear than we want to. And so we'll go ahead and launch that. This thing has a wonderful time getting up into the air. And maybe I did put the landing gear out a little bit too far, but we'll see when it comes time to land that. I think um, if the test run of this is any indication, we're going to get surprising results out of this. So we'll just go ahead and we'll take off as soon as we can, and we will get to a 45-degree angle here. We have a little 5-degree pitch here to help us out. I've been trying to figure out the trim on this thing. The trim is supposed to keep your aircraft in a situation to where it it doesn't pull over too much, but I haven't as of yet gotten it working as planned. We'll go to cockpit view for this. And so this is actually rather nice in terms of the still here. It does like to pitch up a fairly good amount, but that's okay. Unfortunately, we can't really see the trim controls on here, but it turns out we may not need them. The most important things for us, by far, are the, I would definitely say the intake air is pretty important. Electric charge is going to be okay, although we do at some point want to retrofit this so that this ends up being pretty close to what, or to where eventually, because this thing will surprisingly get into space, and it's going to have a near ballistic orbit. I mean, you could call the orbit. Let's pitch down a little bit so we don't run out of intake air. You can call that orbit more or less, you know, I guess an unstable orbit, but in that sense, I mean, it actually does pretty okay. We're already past 10,000 feet, and we need to pitch down a fair amount. I'm going to get down to 15 degrees here. And we can see the moon pretty well. Now, the deal with intake air on this is that you want to get your intake air, in order to keep your intake air, you want to keep the nose pointed on prograde. So we're at 14,000 feet right now, or meters rather, because the Kerbal space program is a metric space program. Before too long, we should be getting re-entry heating. And speak of the devil, there it is. But we're almost at 20k. We'll want to be careful here, because, as it turns out, the deal here is that if we're not careful, we will lose our we'll lose our speed here. And so you can see we're getting pretty close here. We're going to start throttling down with about 10 units rather of intake air. I'm not exactly sure what those units are, to be honest. And you'll probably be a little bit surprised at how efficient this thing is in terms of, its ability to use intake air. Now, are we dropping in altitude very slightly? It's bound to go up a little bit. This, as I said, this thing does have the propensity to pitch up quite a bit. We are gaining a little bit of altitude. You can see we're at some 16,000 feet here. Eventually our prograde marker will move forward and or move to where we're at, and we'll gain a little bit more in the way of altitude. This isn't a permanent thing, of course. And so we are very slowly climbing here, and we're already, I mean, it's not the fastest lift, but we're almost 3 minutes in, and we're already in the upper part of the atmosphere. The middle part, I guess, the not the troposphere, but the stratosphere, or Kerbal's equivalent of it, anyhow. And so the deal here is that when we get high enough, and it will happen, you can see our you can actually see our altitude climbing very steadily. We're going to try to level this thing out as much as possible, and that will be possible because the reentry, or the control surfaces rather, are not going to be effective once we get out of the atmosphere. And so we're already going pretty fast here. In fact, you could see that, it might in fact help if I put up my landing gear. That might lead to a little bit of inefficiency. Yeah, putting up my landing gear definitely did help just a little bit. But we are grabbing quite a bit of velocity here. And I suppose by the time we get to 20K, we'll be at about 1,400 meters per second. And you can see this thing is sipping fuel. So under the right circumstances, this might actually be good on a rocket. And there are, in fact, designs for rockets which do utilize this sort of thing. Oh, it looks like I undershot it just a little bit by about 100 meters per second, but it might be time for us to throttle back just a little bit. Which is counterintuitive. You wouldn't think that by throttling back we continue to gain velocity, but we will. And I think right now it's good for us to level out just a little bit. I think part of the reason for that is that we can keep our nose up longer, or our nose in line with the prograde longer, and we're not fighting as much in the way of air resistance like we are here. I mean, we are in some way wasting fuel, but as a result, the the air really doesn't fight back as much, and you should get less in the way of drag. So let's look at our throttle. Our throttle really isn't too far out there. When this thing gets down to maybe 0.04, we'll throttle back more dramatically. Because when I flew this thing, I got it very, very high up. Higher than you would expect a space plane to go. And we just want to maintain that lift vector just a little bit, not too much. We want to be going at about the, at about the proper speed here. And you'll see that does help quite a bit. That's extending our intake air. We're almost at 1600. I bet you if we throttle down just a little bit more, we can increase that. Even though we're nowhere near flame out at this point, we do want to throttle up just a little bit. We're nowhere near flame out, and that's good. And this might even be a good time if I had rocket engines on to fly our rocket engines, although that's not strictly necessary. I mean, given the amount of fuel we have, that is actually a rather pointless thing to do. Or we're dropping in velocity. We don't want that. Have we reached apoapsis already? We'll bring that up. We're going a little bit too slow. We want to manage our apoapsis just a little bit. Because we are past apoapsis here, which means we're going to have to pull up just a little bit. And we're actually gaining, we're gaining here. So a little bit of wasted fuel, but that never really hurt anybody. We just have to be careful here. And we want our vertical speed to actually get up to this 100 here. Now, I didn't do this in IVA view last time, so this is rather interesting. I've got less of an idea of the proper way to approach this. And we don't want to pull up too quickly here. We'll lose all of our air. We just want to continue moving forward. Or maybe, yeah, if we lower our throttle just a little bit, we're going to pick up speed. And so we're actually pretty high up right now. I was going to say we can look up the window. We're pretty high up above the atmosphere. But, at any rate, we want to continue to climb at this point. Because the more we climb, the more in the way of air we're going to have. And that will, by reducing our throttle, that will make us move a little bit faster. Even though, even though our intake air is dropping a little bit, we are gaining altitude really quickly, which means that as long as we keep our plane near our prograde, that should be fine. We're already at about 25,000 feet. We just need to make sure that our vertical velocity doesn't go too high. And we're in fact only 500 from orbital speed. Now granted this is in the atmosphere and there's drag. We'll just throttle down a little bit. Make better use of that, we'll make better use of that intake air. And we are more or less on prograde, and we're not really losing vertical velocity here, which is nice. I mean, we've lost a little bit, but enough for it to be acceptable. And we're throttling back again so we don't end up abusing our intake air. It's a rare resource up here at, it looks like 27,000 meters. And we can get this thing pretty high. And you'll notice that my prograde is a lot closer to my heading, which is nice. We're almost to 30,000 feet, it looks like. I'll throttle back a little bit more. Now, I'm not exactly sure why your speed increases when you lower your throttle. In fact, let's look at our throttle right now. Our throttle's about midway. I think it could stand to come down a little bit. I mean, this part is the more difficult part, for sure. But at this point, we're the fastest thing on Kerbal because, at least at our space program, we haven't launched anything into space. So the rest of this is going to be all about pushing out our apoapsis and keeping level. We want to raise in speed a little bit, but we want to keep as close to prograde as we can. And that will help us preserve fuel. And we'll be getting, at this point, if we bring up our map view, you can see we've already got, we should be increasing our time to apoapsis here. A little bit. Maybe not. We want to pull way back. There we go. We've been using a little bit too much in the way of fuel. We look at this, we're still gaining speed quickly. I don't know if that just happens to be due to management of intake air or not. but we're pushing our apoapsis forward at this point. Yeah, I think it has a lot to do with the fact that the simulation has slowed down a bit because my computer's a little bit too weak to handle everything. One of these days I will get a replacement. And I guess this cockpit simulation is just a little bit too much for it, but we're on our way to orbital speed. We just have to keep everything uh, down here. I'm gonna try to keep this at half throttle or so. That's a little bit around half, a little bit under 2/3. And at this point, our control surfaces are not doing us much good because to relative to us here, and in fact, we just want to get as level as possible at this point and build up our speed that way. Because it doesn't matter if we're gaining any vertical velocity anymore. We want to push out that apoapsis as much as we can. So we'll pull back a little bit. You can see we're already quite a deal out. And we'll get this guy pushed out before too long. So while we're not gaining much in the way of altitude, I mean, we sort of are because our apoapsis is flattened out quite a bit. And you can see we haven't even quenched yet. We haven't we haven't flamed out, which is really nice, and we're almost at orbital velocity. And so far, we've used even less than half of our fuel. It would be really nice here. We'll throttle back just a little bit, I think. What would be really nice here is if we could manage to keep this thing going until 40 or so K, which I've done. It's hard, but it's doable. But we have to, in that case, slow down just a little bit and make sure we don't float up like we're doing here. We want to more or less be level. As you can see, we're still, we can see the stars now. We're pretty high above the atmosphere. The question is, can we get up here? Or is my piloting going to be inept? We'll pull back the throttle to find out. We don't want to pull it back too much, but we do want to pull it back a little bit. Because the more we can run this, the more in terms of free speed we get. Let's go here. We're level. In fact, I think we're very slowly gaining altitude here. But we need to push this thing forward a bit. get our time to apoapsis up, because we are running very close here. We're at about 34K. We want to remain here in the center. You can see we've already got an orbit going. It's just a matter of seeing how far this orbit will go. And it is going pretty far so far. I think the reason minimal thrust actually speeds us up is because of the Oberth effect. And if you don't remember, the Oberth effect is basically the steal here to where the faster you're going at apoapsis, you can see we're gonna run out pretty soon, I think, because I haven't been flying this as efficiently as I can. But the faster we're flying at apoapsis, or not apoapsis, but at periapsis, the more speed we get out of it. And so this would be a good point for us to use our rockets if we had them. Of course, this ain't a space plane. This is something entirely different. We are getting pretty close here. You can see our orbital velocity has gone up quite a bit. Our surface velocity is about the same, but our orbital velocity is quite level. I'm going to throttle down as much as I can. And we'll burn out a little bit, but because of this design, burnout's not going to be an issue. Because with our design, what we're doing is we've only got one engine, so if we flame out, we don't go into a flat spin. Let's see, we'll crank this guy down a little bit. I think I may have overdone it just a little bit. The question is, will we be able to maintain orbital velocity at this point? I believe the answer to that to be yes. And you can see we're not completely out of intake air here. We're just that we should be out of the atmosphere. We're not entirely out of intake air, and we're at like 40K. If I had piloted this thing better, I think we would get even higher. But there's our 40K mark. As long as we don't flame out, I think we'll be okay. I've just got to maintain this heading, because even the thin amount of atmosphere we're in now will cause us to run out. It's amazing we haven't flamed out, though. In fact, we need to pull this in a little bit further. What's our surface speed? I guess we gotta... We're almost orbital velocity here. And again, we look at the map. We're actually doing quite a deal better. I think we're doing better than I did last time. We've got a lot more in the way of velocity. I'm making this last a lot longer. Oh, there we go. We flamed out. And I don't think we'll be coming back. We'll come back a little bit, but this is the point now to where we have to deal with drag. And so, this will effectively end up being about 80k or so, somewhere between 80 and 70, because we're at 43. We actually do have, we can take advantage of this a little bit longer, I think. They gain a little bit in terms of altitude. At least stall our descent some. But if we put our if we're careful and if we put the right, that may be it for good. No, we still got air. This is fascinating. We didn't even flame out until 40k. That's nice. I've never had a craft that I've designed that had that attribute. It's always, I don't know if it's really doing us. No, it's gaining us altitude. Did we flame out again? I think we did. I'm not gonna dump fuel. I'll just have the engine up a little bit, not too much. Let's just hope that Jebediah Kerbal has his oxygen mask on at this point. Because now, now we're relying strictly on the oxygen. Internal cabin pressure is probably not going to be sufficient to keep him alive. Let's see. We are still gaining altitude. This is way better because last time when I was testing this, I didn't think to keep the engine going. Right now we're going to be aerodynamically at our most stable point if we continue to burn fuel this way. Let's look at our surface velocity. Okay. Are we going to get anything out of that? Probably not. Well, I say that, but I don't really want to fight. I do kind of want to set a record of sorts for a personal record because this is the best I've ever done in an SSTO. I've never been able to get one up to this height, even though it's been flying for 17 minutes or so. I mean, that is really it is really cool to keep it, burning at that point. It's okay. Well, you know what? That's good enough for me. We're losing a lot less in the way of velocity though, even though we are burning a little bit. There we go. We'll have plenty of fuel when we re-enter the atmosphere. Now we do want to be careful not to bleed off too much velocity when we land. We'll just put this in physical time warp. We are doing quite well considering the circumstances. And so, I didn't expect to go to space so easily. But here we are in space. And if we look here, we'll, we'll put this in orbital mode. Now, our axis is quite eccentric, but we'll turn around a little bit. You can see Kerbal from the cockpit, which is really nifty. That's pretty cool. I like that. In fact, maybe it's F1 to kill the UI. It's F2. That's a really nifty screenshot there. And we'll come up over this a little bit. We're gonna have to be careful coming back in. But this is us at periapsis. We can't even see Kerbal anymore. But that's probably though because of the fact that we're pointing retrograde at this point. And I believe that is a sign we've just re-entered the atmosphere. It looks to be the case. Why that is retrograde, I think just because of the way I'm rotated, it's not good to fly backwards. Now, there we go. We'll just level on out here. And we're bound to be off course a little bit. That looks good. We're not going to kick our engines back up until we get back in, but we're going to have some pretty rad re-entry effects, it looks like. We should be losing velocity fairly rapidly, as you can see by looking on the map. We got a little bit of a while to go, but we'll do physical time warp here. Periapsis should drop substantially once we get down here. In fact, we could probably even make it go faster if we nose down, but I want to try to make it to the Space Center, so I'm not going to bother with that. We'll keep this guy going here, because unfortunately for us, our altitude is a little bit too high. So some 4 times time acceleration is good. We want to, we want to make sure that, what is that? There we go. We want to make sure that we don't rip ourselves apart in the process. I mean, at this point, that would be inadvisable. We need to level out and at least level out. I mean, it's I don't have deadly reentry on. Otherwise, that would make for a very interesting experience because I'm going a little bit too fast and I'm not bleeding off enough of my speed. So, where's my G meter? I want to see my G's. When we hit the atmosphere, we could hit some fairly high G's doing this. And we are very we are very slightly off there. In fact, I almost kind of wish I didn't do that because I gave us a little bit too much in the way of tilt there. I should have, oddly enough, I should have used my. I'm not going to do that quite yet. I meant to hit fine controls. I'm going to keep us as centered as possible here. Now, unfortunately, I think the inclination of the runway is a little off. I'm going to try and keep the sky level as best as we can. One thing we can see here is we are going to be landing on the dark side of Kerbal, which is interesting. In fact, we're not going to have much in the way of a good landing spot at all. I'll probably pitch down a little bit too quickly. But that's okay. We'll try to land somehow. We'll find a good landing spot. We've lost a little bit too much in the way of velocity. There goes our re-entry effects here. If I had kept this at about 70, then we would have landed. And I could, if I really wanted to, I could try to hit KSC. But we're not in a very good position to do that, which is problematic. We'll just try to land down here. In which case we'll let this thing run its course. We don't want to have too much of a downward pitch on our prograde because that will make this thing go out of control relatively quickly. But when we get down to several, maybe like 10 meters, we'll turn our engines back on and we'll try to fly to some piece of land that's going to be suitable for us to land on. In which case we'll really see if this thing is reasonable. In fact, we'll cut on our engines now. We'll go at partial thrust here. Surface velocity should be decreasing quite rapidly. And we are now in air breathing mode. The question is, are we still over land? I can't really tell, to be honest. It looks like we will be for a while, so I'm going to try to land soon. And we'll bring up our electric charge too. What happened to my cockpit visibility? Okay. 10,000 feet, that's good enough. And throttle is going to come up. We'll try to make a graceful approach here. And we'll see what's our throttle at. Let's bring that up to half. That looks like it could be a good place to land if we're careful. Of course, I don't know, there's mountains there. And you can't really see too much off or out of the cockpit. But let's get this thing down to a solid 1,000 or so feet before we make that decision. And we are oscillating a little bit, probably because we throttled down. We'll bring this thing to a banked roll here. Unfortunately, there's no good way to control that. It would probably be okay for me to get this thing, like use a joystick on this. Where are we now? We're at 5K. Those hills, I don't trust them. Let's look on the map. Those hills may be the only place for us to land safely, however. But I don't really want to be going uphill. I'll go ahead and I'll do a 45-degree angle here. This land looks quite a deal more flat. Yeah, in fact, that looks way flat. Ooh. We gotta be careful here, because if we're not careful, we'll lose our prograde marker and then we'll spin out of control. Okay, that looks to be a little bit better. And we are losing altitude relatively quickly here. When we get to about 2K or so, or even 1K, I'll put down my gear at the risk of having too much in the way of gear, or having my gear out too early. We don't want to overshoot that, so yeah, we'll descend not terribly rapidly, but we do want to be able to have a little bit of control authority here. So I'll put the throttle down to some amount that doesn't cause us to lose all of our electricity. That way we can sort of have this powered gliding thing going on. Our radar altimeter should be going off pretty soon. Until then, we'll go down to 10 degrees here. Lose a little bit more in the way of velocity. Maybe get this down to 1,000. Or at least 1,000. We don't want this thing to be going down too quickly. 20 meters per second seems to be alright, but that doesn't look like it would be the best thing for us. And now that we've come down, we don't really have much of a choice where we land. I mean, we're more or less committed to land at this point. I mean, we can. Well, I say we don't have any choice. This is a plane. We can glide if necessary. We are about 1,000 feet up. I want to keep the descent speed pretty low. And I want to make sure whatever we do that we don't overdo our descent. It's hard to know when the best place to land is, because that almost seems like a judgment call we have to make. It looks like 1,000 though is a little bit too. We're coming in a little bit too shallow. We might run out of lands to land on if we're not careful. Yeah, we're losing velocity a little bit more easily now. Okay, let's not lose too much in the way of horizontal velocity. Let's bring these engines down really low. Let's put down our landing gear at maybe about 200. I think that will be a-okay. We'll try to land on our tail here. Okay. Oh, dude, we're a little bit too high. I say dude as if there's anybody to talk to. It's just me and Jebediah Kerman in this airplane. But, we're going to be landing very soon. I'm going to, cut my engines a little bit. And let's not overshoot the proverbial runway. I don't know if that means we've landed. Not quite yet. Well, I broke something there. I don't know what it was. Let's take a look. Was it my engine? Yeah, it was probably the result of me trying to land uphill. But as long as I'm not targeting anything, I think I've gotten better at landing. At any rate, this has been Thy Lord Roots, and I will see you next time.